Hello, my name is Kara, and welcome to my application number 5 presentation. On this presentation, we're going to start looking at hypothesis testing. So we received the original claim that all college students will borrow on average $31,000 before they graduate with a 4-year degree. During this application problem, we're going to determine whether or not we reject this or we fail to reject it. And we'll talk about that a little bit more going forward. First thing first, where did we get our data from? Collecting our data. So we actually did a convenience sampling, which is well known to not be the best sampling, but we spoke with students who were entering the MTSU campus. We surveyed the first 300 students that entered the campus, and they were able to tell us how much they have borrowed going towards their 4-year degree. Now that we really quickly talked about where our data came from and what numbers we're going to be looking at, we're going to go take a deeper dive into the exact steps of hypothesis testing. And first is to designate the null hypothesis and alternate hypothesis. So null hypothesis is exactly what the claim is telling us. So we represent that as HO mu. Mu is mean, population mean. Since this is going to be a mean of how much money, an average of how much money that all the students have borrowed before they graduate for their 4-year degree, that's why we're going to be doing a hypothesis mean testing. So HO mu is equal to 31,000. That means that we are claiming on this one, on our null hypothesis, that students on average will borrow $31,000. Now, alternate hypothesis is what we're going to use to test this, to really whether or not that we can go against this null hypothesis. And the alternate one that I have chosen is that HA, which is alternate, mu, meaning average, population average, is more than 31,000. So my claim is that the mu, the population mean, will be more than 31,000. Now, this is the heavy lifting part of our presentation. This is where all of our math will come in, and this is where we're going to get into the details of our steps. So the first thing we need to know is our confidence level. How much confidence do we want to have to deal with these numbers? And so we're actually going to work with a 95% confidence, which is actually a really good confidence, which leaves us an alpha of 0.05. So the very end number that we end up with, which I'm going to talk about a little bit later, we want it to be less than 0.05. If it is more than 0.05, then we actually ultimately what we call fail to reject. And if it's less than 0.05, then we actually get to reject our null hypothesis. We get to reject the original claim that was given to us. Now, going to our next step is going to be talking about the X bar. X bar is our sample mean. So going back to that data that we collected, we actually were able to collect that the mean, the average amount of money that was borrowed for all the students who were surveyed is $29,611.99, which could be already a sign that our alternate hypothesis isn't going to be really able to be able to reject our null hypothesis. But we're going to continue forward because we never know. Just because that number is lower doesn't mean that it won't be able to reject our null hypothesis. And big surprise to no one is we need to know the size of our sample. So we actually sampled 300 people. That is very important to know. And then lastly, our last two steps are actually sample standard deviation. So we actually take all of our data from our statistics and our surveys, and then we actually use that. We're going to use an application, a lovely application, Excel. to figure out the standard deviation. So we'll put uh, we'll put equal std ev dot s. The s is for sample, sorry. So when we did that, the standard deviation, which means the how many change we can really have, is $11,567.73. And that's all information. All those numbers are important to lead us to this final formula that you'll see here, which is t-score. We're doing a t-score because it's a hypothesis mean testing. If we did a hypothesis population proportion testing, it'd be a z-score. We're doing a t-score. So t equals x bar, which we already found is our sample average, minus mu, which is actually going to be the 31,000 that we are assuming is the population average, all divided by the standard deviation divided by the square root of how many people we sampled. And by plugging all those numbers in and then letting the calculator do the math, we actually end up with a t-score of negative 2.0829. This is important because this is going to lead us to our p-value. Our p-value is the one that we are going to actually compare against our 0.05 or alpha. And our p-value is 0.9803. So we actually got our p-value by using a lovely graphing calculator program called Desmos. And you'll just put in t-dist and then degrees of freedom. So the degrees of freedom, which is another reason why our sample is important to know, our degrees of freedom is going to be our sample size minus 1. And then we were able to see our cumulative, and then we were able to conduct a right tail test because we are trying to see more than. We want to see what's more than. So we want to see, we typed in negative 2.0829, and to see, we saw everything to the right of it. And that is going to be 0.98073. I know that's a lot to take in. So we're just going to go to the end of it. Is the p-value smaller than alpha? Is 0.98073 smaller than 0.05? No, it's not. So we actually we were not able to reject the null hypothesis, which means we fail to reject the null hypothesis. Now we're going to go ahead towards our conclusion that because we failed to reject the null hypothesis this time does not mean that we should just say, okay, $31,000. That just might be because our sampling was done wrong, or our hypothesis testing just wasn't right. So we just say we do not have sufficient evidence to reject the original claim and to support our claim. Now, going back to what could have happened to make the hypothesis testing not as able to reject the null hypothesis as we wanted it to, is called a type 2 error. And here's some type 2 errors that could have occurred. So first, the sample wasn't taken random enough. We didn't ask enough random students. We didn't ask students who from different diversities. We didn't include everybody. We made a very biased sample. Next is we probably didn't count, we probably weren't able to count the out-of-state students and non-community college transfers. We probably were only counting those who live in Tennessee because we were collecting samples from those who were entering the campus, not those who were already on campus. And then on top of that, we probably could have encountered some scholarships. So a lot of people actually, unsurprisingly, enter university with scholarships. And so a lot of scholarships could have helped lower that amount that is actually borrowed per se from a loan, but it was actually given to them for whatever great reasons that they deserved it. Thank you so much for listening to my application number 5 final presentation. We found out a lot about hypothesis testing and very, very heavy loaded work that we love to use technology for.